Hello all. In today's video, we are going to learn about linked list by solving some Leetcode problems. So let's start. So this is the first problem that we are going to solve today. This is like middle of the linked list. So what it says is we are given the head of a single linked list, return the middle node of the linked list. If there are two middle nodes, return the second middle node. Okay, so what does this mean is, for example, like in example one, we have odd number of nodes, right? So there is only one middle, which is the node with value 3, so we have to return the address of this one. In the second example, there are even number of nodes, so there would be two middle nodes with value 3 and 4, and in that case we have to return the second, see, return the second middle node. Okay, so the question is quite clear, there is no ambiguity. uh, so let's try to understand first what is given in the solution. So it says definition for a single linked list is given, and this is the definition. Okay, so this is a class list node class which contains a value, and then it has a type of list node type of field called next. Okay, then it has these three constructors. Okay, so if you're familiar with C++, you must be aware about the concept of constructors. Even if you are not, you don't need to worry about them too much. So constructors are nothing but a function which are used to initialize the object, which means putting values in the fields of the class. So for example, take a look at this constructor, list node int val. So when I want to use it, I have to pass a value, and then that value would be copied into this value. So this dot val means the value which belongs to the class, and then this val means this one, the argument that's been passed. Okay, so let's first try to understand some theory of it, of like how this is a how this class definition represents a list node. Okay, so let me draw it out. So if you see, we have a val field which is of type int, and then we have list node type of field next. Okay, so a linked list is a collection of nodes, and in this case those nodes are called list nodes. So how this is a collection, right? Like, so let's look at the structure, like how this would be in the memory. Okay, so it has two fields basically, like that's what we discussed in our last video, that a linked list has at least two fields. One would be a data part and another one would be address part. So this val is the data part here, and then the address is this next, which is this variable, and the val is represented by this variable. Okay, now what happens, like how a next node is connected. So a linked list is something like this, right? There is a node, and then it references another node, and then it references another node. This is a single linked list, right? So let's see how. So this field is important, list node next. So if you have watched my previous video, I have said one thing about the objects, that objects are nothing but references, like they contain addresses. Okay, so object in Java contain addresses. So you can think of them something like pointers. Okay, it's just that we cannot access that address in memory, whereas with the pointers we can access that memory. Okay, so they contain address. So what happens, like let's say there is another node here, okay, of same list node type, then it would have a value field and it would have a next field. Okay, and then the next field of this node can contain the address of this the second node. Okay, and that's how they are linked, and it goes on, like there would be another node, and then this would contain the address of the third node here. Okay, and then let me just remove these fields here from here. Okay, and then the value field would contain the values. So in this case the values are 1, 2 and 3, and then the next field is containing the addresses to the next node, whatever is the next node in the linked list. Okay, so it goes on like this, and then we have the last one, which is the we have 5 nodes in the first example that's been given, right? Okay, so now what happens? So how can we access this linked list, right? So if you see, we don't need the address of every node to kind of know about this linked list, right? Like let's say we have to print this linked list, right? What do we know? What we should know at least, right? And what is sufficient in this case if you want to print this linked list? Okay, so we just need the address of this node, right? And then it should be sufficient to print, right? If we have the address of this node, it should be sufficient to print. How? We would first go to this node, and then we would follow the next pointer, right? We would follow the next field, and then which contains the address to the next node, so we can reach to this node in memory, okay? And so on. So that's how you traverse a linked list. By solving this question, we would see how we can traverse the linked list. So I think we can begin with the solution. Okay. So there are two ways to solve it. So first I would like try to solve it using the naive or the basic, like this could be the first solution that you can think of. Okay, so what could happen is we can count the number of nodes and then we can go to the middle node, right? So if we know that in the first case we have 5 nodes, so in this case, if you see, like if we have 5 nodes here, okay, so 5 by 2, you'll do 5 by 2, which is 2. We know that we have to go to the second node, right? But what second? Like this is 1, 2. This second is index from 0. How I reached here is because this is my middle node in this case, right? So 5 by 2 is 2, so we can go 0, 1, and this is the second index node, right? If you also take a look at the even part, like where the linked list has even number of nodes, 3, 4, 5, and 6, and then we would do 6 by 2, which is 3. So if you see, this is the answer that we have to return, right? So 0, 1, 2, 3, this is the index. If we think of it, the nodes as, if we index the nodes, so this would be the third index node, right? So simple, right? So let's code it. The first approach is taking the count. Okay, so let's take a count, and let's also try to use another concept, which is like creating another method. So let me just create a method which would count the total number of nodes. Okay, so private ints, and as I have said in my previous video, you can use private, just blindly you can use private in solving Leetcode questions if you are creating new methods. Okay, so private int, and you can give it any name, so count, and then so we need to have the address of the first node, right, to access all the nodes of the linked list. So I'm just giving it any name. This head, I mean, this could be any name, because this this variable is local to this count function. Okay, so it won't be like colliding with this head, which is local to middle node. Okay, so that is fine. Let's see how we can count it. We can take a variable for int val. Let's say I would say 0. Then I would say I equals 0, I less. Okay, we cannot traverse on I, right? So what I would do is I would use a while loop. It's fine. While, you can use any loop if you want. While head not equals null, what we have to do is we have to do plus val. Okay, and then head equals head dot next. Okay, and then this would give us the count, and what we would do is we would return the val here. Okay, so very similar to a C++ code, right? This, if you see this count function, is very similar. Okay, now what we have to do, we would take the count here, total nodes. You can use any variable name. Okay, count, and then we would pass head, which is the reference to the first node of the linked list. Okay, and then what we would do is, so we have to traverse till total nodes by 2. Okay, so let's see how we'll do. Okay, so for I equals 0, I less than equals head, so not head, total nodes by 2, and then plus plus I, and then what we have to do is, so 0 head equals head dot next, right? So we have to be careful. We have to see if the head stops at the middle node or not. So let's test it. Okay, so I is at 0, and then head moves to the, and in the same iteration head is moving to the next node, right? So which is 2. So I think we are moving it like one more position. So let's just do it like this. Okay, I think this should be good enough. So let's test it. Missing return statement. So we have to return the reference of the middle node which head is containing. So we just have to return head. Let's run it. So test cases are passing. Let's submit it. And it got accepted. Okay, so that's all. So in this question we learned how a singly linked list is represented in Java, and you can use this definition anywhere. Like if you want to create a singly linked list, like you can create a node like this, and then this would be a representation for singly linked list in Java. So that's one thing we learned. Another thing we learned, like how to traverse, right? So here actually here we are traversing till the end of the linked list. Okay, we can also use for loop. It's just that I'm using while because it comes naturally in this kind of situation to me. You are free to use any kind of loop you want. Okay, what could be the other possible solution here? What if I want to do it in one iteration? And what do I mean by that? Here I'm like traversing, this is one iteration, and then again I have to traverse from head to the middle. So we are doing kind of like 1.5 iteration of the linked list, right? What if I want to use a single loop to do it? Okay, so think about it. I'm going to provide you a solution here. I'm going to explain the algorithm first. Okay, so if we have to do it in single iteration, so let's take the example 1 2 3 4 5. Okay, what I would do is, the idea is to have 2 pointers, and one would move twice the speed as the first one. Okay, so let's say I call this one a slow pointer. I would initialize one pointer here, and I would initialize another pointer here, and I'm calling it fast. So F for fast. And then in every iteration what I'm going to do is I'm going to move slow one node ahead. Okay, and then moving fast two nodes ahead in every iteration. Okay, so what would happen? Let's see what happens in iteration 1. Okay, what happens? So fast moves from here to here, right? Because fast moves 2 nodes ahead, and slow moves 1 node ahead to here. Okay, so this happens. So you see, fast is at 4th node, and slow is at 2nd node. So which means when fast would reach the last node, slow should be at the middle. Okay, we just have to think about handling some of the edge cases, okay, and how to implement it. So here in the next iteration what happens is, like, this fast goes to here, and then essentially it goes to null, right? And then slow would move to here, right? This would be okay. So slow would move to this node, right? So you see, slow is now at the middle node, so this works. Okay, let's take example of even number of nodes. So 1 2 3. Okay, so this linked list has even number of nodes. Let's see how we can do it. So again, slow is here, fast is here, and then we have iteration 1. What happens in iteration 1? Fast moves to position, so here, okay, and then slow moves here, right? Oh sorry, I missed one of the notes, so let me just correct it. Yeah, okay, so this is iteration 1. What happens in iteration 2? Fast again moves 2 positions, right? This time it won't reach null, but it would be pointing to the 6th node, okay? And then what happens to slow? Slow moves to this position again. Just one, slow moves just one position ahead, so it moves to the 3rd node. Okay? Now what happens when in the next iteration, the iteration 3, this fast would be like out, it would move to null, but slow is still pointing to 3rd. So we have to implement it in such a way that if for every fast, like this was not null, so we have to move slow node to like one more position. Okay, so it's all about implementation now. Because you got the idea that we are taking 2 pointers, one we are moving twice the speed and another one we are like so one we are moving twice the speed of the first one. So, and by that, whenever it covers twice the distance, right? So, and we just have to think about some edge cases now to solve it. So let's see how we can implement this one. So as explained, I'm going to take 2 pointers, and pointers in Java are nothing but objects. Okay, so I'm going to take slow, which would be pointing to head, and then fast, which would be pointing to head dot next. Here we have to be careful that if head is null, then this would throw me an error, right? Because null dot next is nothing like we would get an exception in Java. So we have to be careful that head is never null if we are reaching this statement. So let's see what is the minimum number of nodes here. So the number of nodes in the linked list in the range 1. So minimum number of nodes is 1. So we are safe here. Okay, so we don't need to add any checks. Now how I would implement my logic. See this. While fast not equal to null, okay, yeah, so while fast is not equal to null, we'll continue, and then what we would do is slow equals slow dot next. Okay, slow would move to the next position, and I'm not going to increment fast 2 times like in one go. Okay, so what I'm going to do, I'm going to just do, so what I mean is I can also do something like this, okay, but I'm not doing that because that won't solve our edge case problems. Okay, and this can also throw a null pointer exception. Why? Because when you do fast dot next, it might reach null, and then when you do null dot next, like invoking a next on null is like we will throw an exception. So to avoid all that, we would move fast by one position first, and then what I would do is I would check if fast is not equal to null. Then do what? So we don't need this bracket actually. So it's, okay, so then we would move it one more time. Okay, and then when this loop terminates, slow should be at the middle. So we would just return slow. Okay, so this should work. You can take an example and do a dry run of this code, but you got the idea of it. So let's try to run it. So test cases are fine, and if we submit it, this would be successful, as you can see here. Okay, so moving to the next question, reverse linked list. So it says given the head of a singly linked list, reverse the list and return the reversed list. Okay, so if you see example 1, 1, 2, 3, 4, 5, and then the reversed list is 5, 4, 3, 2, 1, right? So we have to take a list, and then we have to kind of, you know, so this is the next question, reverse linked list. We are given the head of a singly linked list similar to the previous question, and we have to, this time we have to reverse the list. Okay, so this is 1, 2, 3, 4, 5, and then we have to return the reversed list like 5, 4, 3, 2, 1. Okay, so how can we do that? So you got the question. Question is quite clear, and for empty, like we don't have, we have to return the empty result. Okay. So how can we return, how can we reverse the list? So there are a couple of like let's try to build the logic here, right? And then we have to reverse this linked list. So which means we have to reach this 5, 4, 3, 2, 1. Okay. So how can we, and then what we are given is a head node which contains the address to this node. So how we can do this? So there are few ways to do this. One is using recursion, which I'm not going to talk about that approach here because we have not talked about recursion on this channel yet. So what I'm going to do is I'm going to do it iteratively using loops. Okay, so how you can build the logic. So this will help you in problem solving. So whenever you have a problem like this, like try to, there are few approaches for this one. What you can do is you can take a node with a linked list with 2 nodes. Okay, and this is the head. What you can do is like try to see how you can reverse this node. So if I have to reverse this node, what I have to do is like I would say put like in the next field of this node I would put the reference of the first node, and here I would have to just make this null. I mean, making null means this link will be gone, and then also I have to somehow point head here. Okay, so now if you follow, if you try to traverse the list, like head would first take me to this node, and then this next would take me here. Okay, so this gets reversed, right? Let's take an example with 3 nodes, 1, 2, 3, and then head is here. Okay, let's see how we can reverse this one. So we'll do the same thing again. First what we would do is we would remove this, we would make it point here. Okay, and then what I want is this we want to remove this node, this link, because we don't want this. Now 2, 1, and then we want to change head to here. Okay, and then this, so if you see like this link is gone, right? This link is gone, so we cannot access this node anymore. So what we have to do is like before changing this link, we have to kind of store it somewhere in some other pointer. So let's say I have another pointer, let's call it temp, and we are storing it here. Okay, now in the next iteration what we have to do, so currently our list is this. If you follow it, head goes to 2, 2 goes to 1, right? So head to 1. What I have to do is head should point to this node, right? 3. So in the next iteration what I have to do, I know temp, I can access this node through temp. Okay, I would assign next value of this node to point to this node 2. Okay, and then what I would do is I would make head point to here, and that would solve the problem, right? So in every iteration what we are doing, we are basically changing the head, right? We are changing the head to point to the new node, and we are also pointing the new node to the previous head, right? So that's what we are doing. So you got the logic, and the same way like we would continue, and that would reverse the list, right? So think about it, take some examples and try to run it and see if it's not clear. Now let's try to code this same logic. Okay, so how we can do this is so we'll do the same thing what we discussed. So first of all, like here if you see in the question, head could be empty, right? The number of nodes in the list is from 0, so we have to handle that 0 situation, right? So I would add a condition here first of all, that so whenever you are like coding on Leetcode, you should always think about the edge cases, handling the edge cases after building the logic. So if head is null, or head dot next is null. What we would do is return head. What does this second condition means? Head dot next would be null when there is only one node in the linked list, right? So in that case, the reverse linked list would be equal to the original list. So we can just return the head. So in both of these conditions, we can simply return our head. Next, what we would do is we would take a pointer. Okay, all right. And then what we would do is we would say this is the temp that that we in the explanation this is similar to what temp variable was doing. So while ptr not equal to null, okay, what we have to do is we have to store the address of the next node so that it doesn't get lost, right? So okay, let's note temp equals ptr dot next. Okay, and then what we have to change few addresses. Okay, so what we have to do is for current ptr dot next equals head, right? Ptr is the current node that we have to reverse, so its next would point to head, and then head would be the new ptr. Okay, and then ptr should move to the next node that we have to reverse. Okay, so you got the logic. And now we have to return head. Okay, so let's try to see, so let's try to run it. Okay, okay, so this is wrong answer. Why? It says found cycle in the list node. Okay, so what does this mean? Like there is a cycle. So cycle means that we are doing something like this, 1 2 3, and then there's something like this in the node. So what is happening here is then that when they are trying to traverse the list, we're going to 1, then to 2, and then to 3, and then we're basically traversing back to 1, and then so this is a kind of loop or cycle. So that's what. So why do we have a cycle here in our solution? Is what we are doing is 1 2 3. We have this list. We are reversing. So we are changing this to 4, this to 3, this to 2, and I think we have, and this is 2 1. But we have not changed this link. Okay, which was our original head. We have never changed this link. And this is what is causing the cycle. Head is also pointing correctly to 5, but what is happening is 5 4 3 2, when we are traversing it, we are going from 5 4 3 2 1, and then we are going back to 2 and again back to 1. So this is where the cycle is. So let's solve this in the code. So to solve that, what we have to do is we just have to add a null here and should be good. Got it. So this is working fine as expected. Okay. So if you didn't get the logic, let me know in the comments or on the Discord channel, and we can discuss more. So let's move on to the next question, which is reverse linked list 2. And it's a medium question. So what does it says? Given the head of a singly linked list and 2 integers left and right, where left is less than equal to right, reverse the nodes of the list from position left to position right and return the reversed list. Okay, so instead of reversing the entire list, what we have to do is they would be like we would get left and right, and then we have to just reverse the nodes between those left and right. Okay, so let's see example 1. So the list is 1 2 3 4 5, and left is 2 and right is 4. Okay, So and is the second node, so indexing starts from 1. So this is the node with value 2 is my second node, and then with value 4 is my fourth node. So what I have to do is, so if you see the output, they have reversed like 2 3 4 to 4 3 2, and the rest of the linked list remains the same. Okay. uh, Second example is just with a single node, so left and right both are same, and in this case like there would be no difference in the reversed list as well. Okay, so how can we solve this? So if you see, part of the solution would still be same, right? So and that's how like you should think about in problem solving, as how you can relate, how you can reuse some of your older solutions. Okay, so if you think about this, we still have to kind of reverse some part of the list. Okay, so let's think about the logic. Let's try to explain the logic here. So to understand the logic, let's take this list, and this is from example 1, and we have to so left here is, left is 2 and right is 4. So basically we have to reverse the part of the linked list between these nodes. Okay, and then rest of the linked list remains the same. So this part and this part, anything before the left bit, other than between left and right, would remain the same. Okay, so how can we do this? We already learned how to reverse a linked list, right? What do we need for that, right? So if you see, our older solution used to work on like we needed to pass the reference to the first node, which is head, and then our last node should be pointing to null. Okay, so here this list is the original list, the last node is the part that we have to reverse, this 4 is still pointing to 5, but if we want to reuse our previous solution, this 4 should point to null. So if we make a list like this, and let's say this is a head or any other variable, and if we pass this list to our first solution, the original reverse list solution, this would reverse it, right? It would reverse it to 4 3 2 and return the head, right? And then what we have to do is, whatever linked list is present before this, okay, and whatever linked list is present after this, we have to just connect. So there would be this last node, and we have to just connect it to the reversed part, and then the last node of the reversed part would contain the address of the next portion of the linked list, and that would solve our question, right? So that's how we'll try to code. That would be our logic. In case of linked list, we have to think about little bit about the edge cases, right? So I can think of one edge case at this moment, that is like when we have to reverse from 1, right? So what I mean is, let's say in the same example, if I say, so left, if I say left is 1 and right is 4, so the solution should be like 4 3 2 1. How is it different than the previous example, than this example? Is that in this case we have to change the head as well, right? Because this would be the new head, right? This would be my new head that would be returned, right? Here in this example, if you see in this example, if this is my head given in the problem, this won't change. Like in the solution also, like this would remain same, right? So this is one of the edge cases that we have to think about. Other than that, I think it should work. Okay, so let's just code it and see. So let's try to code the solution. So what I'm going to do is, I'm going to copy the existing code that we just did. So I'm going to copy this function that we wrote for reverse list, and first thing I'm going to do is I'm going to copy it in this class, okay, in this solution. So again, this could be public or private. So we have seen one example with private. Let's keep it public. It doesn't matter at all. Okay. Now the logic, what should we do here? So as we said, we have to first prepare the list so that we can use this function. Okay, so let's see what we can do. So I would take 2 pointers, list begin, initialize it to head. Both of them would initially be initialized to head. Okay, so the idea is that begin would take me to the left. I mean, I'll use left index and I would traverse, and I would set begin, this pointer big, to the first node from where we want to reverse. Okay, so let's do that. I less than, I think how many, okay, let me first write the logic. Okay, and so for a linked list, again we have to see if we are using it correctly. So if you see this begin.net, so for I is equal to 1, I'm incrementing begin to the next node, like initialize it with head and then it's to the next node, next to the head node. Okay, so I think we are moving it one position more. So what we have to do is we can do it in any way, but I would do it like this, like I would reduce this left -1. Okay, similarly we would also need the last node, right? Because we have to set it to null, and also like we have to keep a reference for the portion of the linked list beyond that last node. So let's do that. Again, you have to verify that this is been set correctly. So I'm trying to set it to this node 4. In the first example, this should be set to 4. Now what I'm going to do is I'm just preparing my linked list so that I can reuse this reverse list function. Okay, so why I'm doing this is I want to keep a reference of the portion of the list after end, which we should keep. It should not get lost, right? Because we have to again link it to the reverse list. So let's see what we would do again is, okay, so we have stored that reference in temp, and now I'm setting null to the last node of the part that I want to reverse. Okay, then end is set to temp. Okay, now what I want to do is, okay, now I can call reverse list with begin. Okay, and I would, where should I, like this would return me a pointer to the reverse list, right? So where should I store it, right? Begin.next, right? The reverse list. And then what I would do is I have to link the remaining part, right? So okay, so I would traverse to the end of the reverse list here, and then what I would do is, right, and then okay, so I have to just return the head. Okay, so again few things to consider. edge cases. So I have seen that here what could be, so n starts from 1, right? So that means that there would at least be one node, so we don't need to handle the empty linked list scenario. Okay, that is fine. Another thing to take care of is setting beginning and end correctly, right? And then rest of the thing is simple, right? We are just here, like in these three statements, we are just preparing our list, like we are setting the last node next to null, so that we can reuse this reverse list function. And then once we get this reversed list, we are not doing anything, we are just kind of traversing and just linking all the, now we have three linked lists that we need to combine, and that's what we are doing here. Okay, so head does not change at all here. So we'll add that condition, but let's first see if this works. Okay, so we got time limit exceeded, and so that means that we aren't able to terminate some of the loops. Okay, so if you look at it carefully, this is where we made the mistake, right? Because beginning is set to, so this is not, like we don't want to reverse from big. So if you see this line, this would take big to, for if I talk about example 1, this would stop big at 1. Okay, why? Because you see for the first example, our left is 2, so I is left minus 1, which is 1. I'm initializing I to 1, and so it won't run at all, right? So beginning is at head at this moment for first example. So what we have to do is we have to kind of pass reversed big dot next. Okay, so let's see if this fixes the problem. Yeah, so both of the examples are successful here, but we talked about one of the edge cases scenario, right? In that case, let's add that test case. Let's modify this one. Left, let's modify to 1, and let's see if this works. No, right? Because again, as I said, in this case, in that case, we have to modify the head, because now since our left is 1, which means we are reversing this portion of the linked list, and so 4 would be our, like, the new head. So let's handle that. So I'm going to put a condition here. I would say if left equals 1, then assign to head. Okay, big or head, we can use anything, else do this. Okay, so I just added one condition to handle that edge case. So now you can see with left is equal to 1, it's successful. You can add few more test cases and try to validate the solution, or you can submit it. So this works. Okay. Okay, so that's how you reuse a solution. And in problem solving, whenever you encounter a new problem, you should always think of how you can reuse your existing logic that you have worked on to solve this problem. If you can, that is the best way. Let's move on to the next question. So this is our next question. Delete node in a linked list. Okay, so this says there is a singly linked list head which we want to delete a node in it. Okay, so this is a question. You are given the node to be deleted. You will not be given access to the first node of head. Okay, so it says that we won't be given the first node. Okay, the access to the first node. So we would just be given, so this list node, this contains the reference of the node which gets deleted, which has to be deleted from the linked list. Okay, all the values of the linked list are unique. Okay, and it is guaranteed that the given node is not the last node in the linked list. Okay, so we have to kind of, when we read this problem, we have to see what is this, what is given to us and what is the solution, and like how, like, we have to first try to understand the problem. Okay, so what is exactly given? It says delete the given node. Note that by deleting the node, we do not mean removing it from memory. We mean the value of the given node should not exist in the linked list. Okay, so previously it mentioned, the question mentions that all the values in the linked list are unique, and so next it says that by deleting they mean that the value of the given node should not exist in the linked list. Okay, so we have to get rid of that value. The number of nodes in the linked list should decrease by 1. Okay, and the values before node should be in the same order. All the values after node should be in the same order. So we just have to delete this node that has been given. All of the remaining linked list should remain same. Okay, so for example, let's go to this example 4519. Okay, and this is the node that would be passed to our function, and the output should be like 419. Okay, if you take this example 4519, and then after the output should be like 459. So these are two examples, and it also says that we won't be given the last node. The given node is not the last node in the linked list. So let's see like why it mentions this and what is the problem here. So let's try to understand what's been given to us here. So if you see the example, so there is a list. For example, this is given 4, 5, 1, 9, and then it says that the node, we would be given a node address, and that would be pointing to the node that we want to delete. Okay, but what is the problem here? Like if we are given heads, if we would have given head in the problem, then what we can do is like we can traverse, we can go to this node, and then we can basically set this link to point to the next node, and that ways we can skip this node in the solution, right? So when we pass now what happens, this linked list is just 4 and then 1 and then 9, right? But here we are not given head, so that is the first problem that we have to deal with. It says that all the values are unique, and by deletion they mean that that value should not be present. So it means that in the result there should not be any node with value 5 in this case. Okay, and it also says that we will not be given the reference of the last node. Okay, so which means whatever is the last node, that would never be given in the input. It means we don't need to, we would never have to delete the last node. Okay, so how can we solve this? So we saw that we cannot use the traditional method of deleting a node in the linked list, right? Which is to just skip that node in the list. Okay, so I would suggest pause this video and think about it for 5 minutes at least. Okay, but this is what we can do. So what we can do here is we can copy the existing values to the right. So in this case, this is our list 9, and then if we have to delete 5, what I can do is I would copy this value here. Okay, 1, then I would go to, like, I would have a pointer, I would travel here, and then what I would do is I would go to the, I would see what value is present in the next node, and I would copy it here, and then I would move here. Okay, and then since this is the last node now, so what we can do is if this is the last node, then this pointer has to be destroyed, like this should be set to null. So what is the resulting list now? 419, right? 4, and then this node is now, node now contains value 1, and then this node contains value 9. So that's how. So we can keep 2 pointers. Okay, let's take one more example, the second example that's been given, 4519. It's the same example, only thing is this time we have to delete this node. Okay, so what we would do, we would be given reference to this one, so node would be pointing to this. We would take another pointer, let's say we would call it what, next. Okay, next will point here, and then what we would do is we would first, what we would copy the value from next to this node. Okay, and then what we, so this becomes 9, and then what we would do is we would move node and next one position to the right. Okay, so next moves, next would now be equal to null. Why? Because there is no node here. and then node moves to the next node, which is 9. Okay, and whenever we reach a position where next is null, then we know that the node would be pointing to the last node in the linked list, and we have to remove this one. Okay, so this we have to slightly modify, because now to delete we have to modify this link, right? So what we would do is, instead of moving these, okay, node would still, let's say node is still pointing here, and then next is pointing here only. Okay, so let's go back to the previous state. Okay, so next is here, node is here. What we have to do, we see that next dot next, or let's rename this as well. This is, let's call this a simple ptr. Okay, so we would see that if ptr dot next is null here, right, because this node doesn't have any next node. Whenever this is the case, we know that ptr is pointing to the last node, and since node is a node previous to ptr, so what we have to do is we can just simply remove this pointer, and that would solve our problem. Right now the linked list is just 4, 5 and 9, so which is the solution. So let's try to code it. So let's take a pointer, and I would say node should never be null. Let's see. Okay, so the minimum number of node is 2 in the list, so this would never throw us null pointer exception, so we are safe. Now what we would do is, while ptr dot next not equal to null, what we would do is we would copy the value. Okay, so node dot val equals ptr dot val. Okay, and then we would move node equals node dot next, and ptr equals ptr dot next. Okay, we are moving now. When ptr dot next is null, this loop would break, right? And in that case we have to do this one more time. Okay, so we would still have to copy, and there is no need to do anything else. We would copy the value from the last node to the previous one, and then what we would do is we would say, right, okay, so I think and then we have to return, or we don't have to return anything, so we just have to set the list correctly, and then it would be verified. So let's also read about this custom testing part, which we skipped. Okay, so it says, for the input you should provide the entire linked list head and the node to be given. Okay, so this is basically about if we want to test our custom use case. Okay, okay, node should not be the last node. Okay, so if we want to try out our code in on our own custom test case, then we should follow these instructions. So it's nothing special. Let's try to run it. Okay, so it passes both of the cases, submitted. Okay, so this works now. All right, so that is it for this video about linked list and problem solving and Leetcode with Java. So here we learned that how a linked list can be created in Java, how it could be traversed, how a node can be deleted. Yeah, and we also talked about problem solving in general, which would be helpful in all the aspects, which is basically to reuse our solutions. Okay, think about like the logic in such a way that we are able to relate it with some of the logic that we have already built, so which is helpful. So thanks for watching.